Consider the differential equation dy dx equals 3x squared. We can multiply both sides by dx to get dy equals 3x squared dx, integrate both sides to get y equals x cubed plus an arbitrary constant c. Now let's look at this differential equation here. The derivative of y times x with respect to x is 3x squared. Well, we could multiply both sides of this by dx to get dyx equals 3x squared times dx, and then integrate both sides. If we integrate d of something, well, we just get whatever that something is, y times x. And if we integrate 3x squared, we get x cubed. And I'll just write the arbitrary constant on the right hand side, call it c. We could also think of doing the left integral here as the integral of 1 times dyx. We're integrating 1 with respect to yx, so we just get 1 times yx. Finally, we can divide this by x to get our solution. Y is a function of x. This differential equation is called an exact equation. We can just solve it by integrating both sides. Here are two more examples. They're quite straightforward. Here is the general picture for the last example we did. We were differentiating some function of x times y with respect to x, and we had some function of x on the right hand side. So we multiply both sides by dx. If we integrate d of f of x times y, we get just that, f of x times y, and we integrate g of x, d of x, and then finally to get y we just divide across by f of x. Okay, let's go back to this equation again. Straightforward when it's in this form, but we can change the form of this equation by actually differentiating y times x with respect to x. We have a product here, so we have to use the product rule for differentiation. So we take one factor in the product, y or x, well actually x is shown here first, multiply that by the derivative of the other factor in the product, so we have x times dy dx here, plus y times dx with respect to dx, which is just 1. So here we have, well, we could have done it the other way around, of course. We could have said y times the derivative of x with respect to x, which is 1, plus x times the derivative of y with respect to x, which we just write dy dx, since we don't know what y is as a function of x, so we just write dy dx. So this is just a product rule. So we could write the left hand side like this, x dy dx plus y, and now our differential equation is not so obvious to solve. So the left hand side here looks like the product rule for differentiation if this equation is to be an exact equation. So in general, we want the left hand side to look like this. Some function f times dy dx, well, f is some function of x, like f of x is just x in this example, plus y times the derivative of the function f. Well, the derivative of x is 1. So comparing here, f of x is equal to x, and f prime of x would just equal 1, so we would just get the left hand side here. So if our differential equation looks like this, then we can write the left hand side as the derivative of y times f of x. So if we apply the product rule to this, we just get this here. Let's look at this example here. Notice that we have this function x cubed, but its derivative 3x squared appears over here. We also see dy dx and y. So this thing looks like the derivative of some product. And indeed the product is y times x cubed. So if we use the product rule, we will have y times the derivative of x cubed with respect to x. That's y times 3x squared. That's that second term there. Plus the second term, x cubed times the derivative of y with respect to x. So that's x cubed dy dx. So we need to look out for that. And when we have it in this form, we just multiply both sides by dx and integrate. So we integrate d of yx cubed, well that just gives us yx cubed, and we integrate x dx, well that's straightforward, and the constant of integration appears on the right hand side. Finally we divide across by x cubed to get y as a function of x. In this example here we see that cos of x is the derivative of sine of x, so we can actually write the left hand side as the derivative of y times sine of x with respect to x. Again, using the product rule, we have y times the derivative of sine of x, which is cos x, so we get y cos x, plus sine of x times the derivative of y, so we get sine of x times dy dx. and now we just multiply both sides by dx and integrate, so we get y sine x on the left hand side, and the integral of cos x is sine x. We can divide both sides by sine, so we get sine x over sine x is 1, and c divided by sine x, well, that can be written as c times cosec of x, where cosec of x is 1 over sine x. Let's look at question 5 here. We want to show that this equation is not exact. Well, you know, we have x squared here. If it's exact, then the derivative of x squared should appear on the left hand side, but the derivative of x squared is 2x, and we don't have 2x, we have 3x here. So that proves that it's not exact. So we cannot write the left hand side as the differential of a product. We cannot write the left hand side like this, d of x squared times y with respect to x. Okay, if we start to use the product rule, we get the first function x squared times the derivative of the second, so we get x squared times dy dx. That works out okay. That gives us this term here, but then we have to take the second term y and multiply by the derivative of x squared. The derivative of x squared is 2x. The problem is that we have a 3 here, so that's not going to work. Multiply the equation by x and show that the resulting equation is exact. Okay, let's see what happens if we multiply by x. Well, we get x times x squared is x cubed, and we have x times 3xy, that's 3x squared y, and on the right hand side we have x cubed by x is x to the power of 4. Now, it looks like we can write the left hand side as the derivative with respect to x of x to the power of 4 times y, like we saw in previous examples. Well, actually, I'm sorry, x cubed, of course. So this term here appears here, and then we just have y. It's straightforward. Okay, so yeah, if you apply the product rule, you'll see that this works out. X cubed times dy dx plus y times the derivative of x cubed with respect to x. But the derivative of x cubed is indeed 3x squared, so this does work out. Okay, so it's equal to x to the power of 4. Let's just quickly solve this. I'll just write it down here. We have d of x cubed y equals x to the 4 times dx. So we integrate both sides. So we get x cubed y equals 1/5 x to the 5 plus a constant. Finally, we divide across by x cubed. So we get 1/5 x squared plus c over x cubed